problem that involves the sum of the digits, which turns out to be useful computationally in some types of problems. Now, just a quick example, like if we have the number 2, 3, 1, okay? The sum of the digits here is exactly what it says, 2 plus 3 plus 1. What does that equal to? It's equal to 6. I can handle that, okay? So what we're given right here is that x and y are two natural numbers with the sum of digits 25 and 26, respectively. That means that x, the sum of the digits of x is 25. We don't know what x is, but you're given that the sum of its digits is 25. And the same with y, we don't know y, but we know that it has the sum of its digits is 26. We also know that x plus y sum up to 15,288. Okay, now we want to find the remainder, not of x plus y, but of x squared plus y squared when it's divided by 9. Okay, now let's move along. Now, we're using this part of the problem first, the 25 and the 26. Now, a lot of you have seen this, but I'll just briefly tell you why it's true. It's because 10 raised to the n for any natural number, okay, is congruent to 1 mod 9. Okay, and this is the equivalent of talking about division by 9, okay? Now, this just comes quickly in a number theory course if you just realize a simple truth that just plain old 10 is congruent to 1 mod 9. Because 10 minus 1 is 9, okay? 10 leaves a remainder of 1 when it's divided by 9, okay? And so you can exponentiate. You have to prove this in a number theory course, but you can square both sides of the equation. We'll call this congruence in equation. And that's what happens here. If you keep squaring, you get this, and then 1 to any power is just 1. So anyway, that's why this is true, because all the powers of 10 just become 1. Okay, so that's why we have these conditions. Okay, x itself, whatever it is congruent to 25 because of this truth right here. And it's very easy to see that if you just write out 25 as 2 times 10 to the first plus 5, right? Similarly, for larger digit numbers, okay? Now, you can also multiply congruences together. When you multiply 26 and 25, you get 650. Now, I didn't show the work here, but if you divide 9 into 650, you get a remainder of 2. Congruence arithmetic or modular arithmetic is sometimes called remainder arithmetic, okay? So we know that xy is congruent to 2 mod 9. Now, you see, why would we be interested in that? Well, we know that when we expand out x plus y quantity squared, we get an xy right in here, right? See, so, and we are interested in what is the remainder of x squared, or what is the remainder when you divide 9 into x squared plus y squared, okay? So automatically we know that this part is just 4 in mod 9, okay? Now, but we're still a little stuck here. What do? Well, another thing to notice, and I'll just write it up here, this turns out that if you divide 9 into 15,288, which is what x plus y is equal to 2, you actually get a remainder of 6. And we can write that as we can write that as x plus y is congruent to 6 mod 9. Okay. Again, y'all didn't show the work, but you could, if you divide 9 into 15,288, you will get a remainder of 6. I won't bother you with showing that computation. Okay, but what does that mean? Well, we have x plus y is congruent to 6 mod 9. So what we have right here is 6 squared, right down here, is congruent to x squared plus y squared plus 4. And y'all, it's understood that it's modulo 9. I won't go to the trouble to write down modulo 9. Okay, but guess what? 6 squared itself is congruent to 0. See how you can do this just like it's a regular equality. Why is that congruent to 0? 6 squared is 36, and 4 times 9 is 36. 9 is the same as 0 mod 9. Okay, So what we have right here, this leads to a -4. Okay, I'm bringing this 4 to the other side is congruent to x squared plus y squared. Now right here we've done most of the work, but you're saying -4. How do you get a remainder of -4? Well, you don't, but you know that -4 is congruent to 5. And y'all, let me write this up. Sorry, this is congruent to 5. Why? Because 5 and -4 are 9 apart. Okay, that's another way of looking at. Okay, so the answer to the question is 5, folks. Because we were asked, what do you get when you divide, what remainder do you get when you divide x squared plus y squared by 9? And so, y'all, that is the answer. Hope you liked it. Hopefully I did the steps in the right order where it makes sense. But that is the answer to the problem. And let me just write it up right up here also. 5. Okay, good day.